I have one. We're just going to get started here. So I did start the recording, and let's just jump in. So today we're going to be talking mostly about classes. We really have like just some different examples with classes to go over. I think it's a useful concept that we test in the course. We do test it. It's like a big thing. We don't really push it, as in like there's not too much actual problem solving you need to figure out with classes. It's more like if you understand how the code works, then really things follow from there. So let's just jump right in. And Sarth was nice enough to develop a notebook for, when I say Sarth, I mean the other TA, was nice enough to develop a notebook for this tutorial. And so I'm probably going to use a notebook for the first part, and then maybe not for the second part, but we'll see. So let's open her up here. Okay. What are objects and classes? So yeah, basically Python is a object-oriented programming language. And what that means actually is more so in Python than in many other languages. So there's different ways. In Java, for example, your main program actually has to be an object as well, called a class. Yeah, I mean, you know that. So the whole program is written in a class. Python is a little differently because it appears almost like a scripting language where it runs top to bottom without how Java or other languages work, where you basically have an entry point. So you have a particular name that will always be executed first, and from that name, basically like a main function or a main class, everything else will be executed. So Python things run top to bottom, but what you see behind the scenes is that everything is an object, meaning there's no primitive types where there's just the type. Everything has certain properties. What do I mean by that? Well, if we take a Python terminal, okay, we can do this, right? So what you notice is that this 3 is an object because there are functions defined on 3 that actually work. And if we actually look, here we go. Oh, it has to be for a dictionary. Well, that's okay. I mean, the idea here is actually that, and I should point out, what are objects and classes? And oh, actually, this happens to be here, kind of. They kind of explain this. So the difference between an object and a class is probably stands for classification. And essentially what a class is it is a blueprint, as in it is some code which defines a structured collection of data and some methods or functions, operations that can be executed on that data. So essentially classes have 2 parts. They have some properties, or sometimes they're called fields, and those are basically variables which are specific to a class. But here's the confusing part. You can make multiple objects from a class, and they don't actually share the same properties. So essentially, if when I have a class, basically, right? So this car class, let's say, I'd have a class car, but I couldn't do car.brand. What I could do is I could say Toyota equals to car Toyota make. Wait, that is Toyota. What the hell is the difference? Sienna, I think that's one. And then you could say like 130,000, $10, because that's definitely how things go. And then 6, and we can even leave this blank, right? And what we could do now is, instead of saying car.brand, which will be empty, we can instead do Toyota.brand. And the reason why is because car will be, and we haven't defined any of this stuff yet, I'm just trying to give a bit of an intro here. Car is actually like a blueprint. So it's just saying, when we do create a code, it's going to have these properties, and we'll have certain methods that we can operate on it. This is actually storing the actual, like an actual instance it's called. So the actual data there. So yeah, in Python, everything is an object actually. Everything, variables, numbers, functions, all of them are objects. And so we want to figure out how do we create objects ourselves. So let's do that. And by the way, you don't have to do this part, but I do like it. I think it makes it cleaner. Well, actually, that could be a floating point, and that could also be a floating point. And resale value, which should probably be a float as well. Now, what you're probably asking as well, what do those do? In this case, actually, in Python, they don't do anything. They technically speaking, they don't do anything, at least not in Jupyter Hub or in Jupyter Notebooks, but they don't do anything generally to affect the behavior of the code. They just are helpful to see it all at the top and remember, like if you're documenting or something like that. Where you actually do things when you're going to define, like assign values to these variables. So what you do is we're going to write def init. And this is a special function name, and it's automatically called when you do this, car. What's actually happening is it's calling car.init. And so this is just how Python works. These, usually when they have underscores before and after, it's a special variable, and we'll see that in a moment. But you can see here, right, that this is how this works. So let's define this function, and we can take certain parameters as usual. And there's one change, that everything we do, every function that we define within a class, meaning that it's attached to a class, has to have the first parameter self. And if you want to type it, it would be self car, but I think I normally don't, because I let Python do whatever it wants with that one. Now, the important thing to note here is when you actually call the function, you can just ignore it. You basically act like it's this. Python will automatically pass in the class. Now, what is self? Self is a variable that only exists within classes, and it refers to that class. Now, to be clear, it doesn't refer to the class car itself, but rather whatever the object is. So like when I create a new car, whereas before I said you can do Toyota.brand, you won't be able to do that in a function because there won't be that Toyota. So instead we write self, and that's equivalent. It's referring to the current object, no matter what the current object is. So now we'd want to do self.brand equals brand, self.make equals make, and yes, this is tedious, but this is how you have to do it. Like that. Now, yeah, in Python, you cannot ever refer to one of these variables just within just its name. You have to do self dot, and dot is the syntax to connect any sort of thing with classes and its properties or functions. Okay, so it's a lot to get around, but I think it's manageable. So one thing I'll note, there is something actually called Python data classes, which makes some of the stuff easier. And if you want to, you can feel free to learn it on your own time. But essentially what you do is instead of needing to write this tedious init method, you could just import the data class decorator, and it will basically do that for you. So you can see it generates it in it. So we could actually do this, and I'll just put in, I mean, actually, it's probably easier. It's nicer to do that. So I'm just going to comment this out and say, oh, no, I won't comment it. I'll do another copy of this. I'll wait till we're done this function, and I'll add that. So then, let's just add some stuff. Okay, drive. So def drive. So we want a function, which of course we're going to automatically start with self, and then we will want to decide on what the parameters are. Well, in this case, really all we need to do is we need to probably increase the kilometers and decrease the resale value, right? I think that makes sense, right? The more you drive the car, you know, the lower the resale value will be. So let's do that. And one thing we could do is we could, you know, use some mathematical function. So what I mean by that is, let's say this is in percentage. Okay, so let's start off with just affecting the kilometers. So we would do self, and then we would do distance, which will be, in this case, a floating point as well. And in this case, we don't need to return any value. So now what we'll say is self.kilometers plus equals to distance. Right, makes sense. So every time you press drive, it will increase. Every time you call drive, sorry, it will increase the kilometers. But what we also want to do is decrease the resale value. Now, the way I would normally do this, let me see how this works actually. I thought so. Okay. This is a bit of an advanced concept, but I'll show it in a second. It depends what we want to do with this resale value. We could make this an actual value, and then we could say, well, he said here it's initially that, so we can actually just do this. Let's do it in percent. But there are other nice ways we can do this. So one thing I want to show, and I'll do that in the second part actually. So no, let's do it normally for here. So this will automatically initialize to 65, but actually I'm not 100% sure that it will. So let's just do that anyways. Or actually, now that I think of it, let's do it like this. Let's take in a percentage. And what we'll do is we'll just make the resale value the actual thing of the price. So we'll say price times 0. Or actually it would be times, well, no, we know what it is. So we can just do times 0.65. And then after that, we can actually look in concrete numbers, right? So let's do this now. Let's say we want to calculate the reduction. We can say 0.65 minus the number of kilometers, let's say, the total number of kilometers, times, what do we think? Like, well, it'd be divided by 10, let's say. So that way, if you have 100,000 kilometers, it will then only be worth 55%. Okay, let's do 5. It's a bit steeper. And naturally, this, I guess we need to do this as an edge case, right? Because then if it gets below 0, we want to make sure we are just, oh wait, not 0. That way, if self.kilometers gets really high, like if it has 500,000, like we don't want it to be worth a negative amount. And no, this is not a correct formula, but this is an idea. And so all we need to do now is say, right, this is the price reduction. And so we can say resale value is now going to be equal to, we can just recalculate from scratch every time, self.price, sorry. That makes sense? And I guess if we want to change car, we can do like, you get the idea. Now, if we want to use a data class version and just we probably have to import property as well. No, maybe not. Okay. Okay, so basically what I was trying to show here, so what you could do, right, is in this case, right, every time we're actually calculating the resale value. So there's no real reason here for the resale value to be a property. It would be much better if we could first make this into into something that's just computed on the fly, right? Because we always know this. If we have the price reduction, then we can just always get this number, right? Because we just have the kilometers. So we can take this amount and calculate it and then do the resale value. So why don't we do that, right? Well, so what we can do then is we can delete this property. And instead of doing this here, all we need to do is create a new variable called resale value, so a new function. And it just needs to take the parameter of self, and then we can say return, or we can say reduction again. We can just move this over actually. And then we'll say return this value here. Oops. Does that make sense? Just make sure.
Yeah.
So that'll work. Now what we can do in Python, and this is what I was trying to say, is the only difference is when we want to access this, if we do, watch this, right? So if let's create an example here. This is the one it's going to run. So we can say, call it car advanced. And you don't have to know this stuff in car advanced. This you do need to know, but what I'm about to show you don't. So what you'll notice is if we do Elon's car advanced. Kilometers 10,000. Price. I don't know, probably 80K. I don't know. Let's say 75K. Let's see that. So now we can say car advanced, so Elon's car, not car advanced. And it will give us Tesla. Now if we do price reduction here, what do we notice? It'll say has no resale value, sorry. Do move this. It's going to say bound method, blah, blah, blah. Why? Because this is a function, right? So we actually need to do this. Well, what if we don't want to do that? Well, Python has a nice little trick for us called this property decorator. You don't need to understand it, but really what it does, it just changes the syntax around. So now this is going to be a float. And so if we do it like this, now this behaves like we want. So basically this allows us to have a function which behaves like this. So it's like a computed property, but it's the same idea. Just a cool thing if you want to know for syntactic purposes. We're not going to ask you to do this, but it's a good thing to know. And if you feel like doing this in your own solutions, feel free. Okay. So that's one. The other thing I wanted to do is the data classes. So we can do it's probably from data class. Yeah. Data class. And then of course we can a class, and you can see the theme here with lots of these, and basically what that does is eliminates this part. And we should still see identical behavior from this function. Cool, right? And we'll notice too, like if we print this, and then we Elon's car dot drive for 1,000 kilometers. We print. We see different amounts. Now I don't think this is the correct amount. Definitely not. Oh shoot, it should be minimum. Yeah. No. Self.kilometers. Oh, of course, because it shouldn't be by 5. It should be by, it'd be 100,000. So we want like 5,000, and now it should be min. It'd be 50. What am I doing wrong here? It's a purely mathematical mistake which I'm making. Okay, I see. So now it's 1 or 1. So it should be another 0, and that's why. And now it should be min. There we go. I mean, it's obviously wrong, and but like it's not actually inaccurate, but that's the idea. Just gonna copy this above. Okay. And you can see this is just quite a bit cleaner. Okay. Now let's move on to kind of the bulk of the tutorial. Okay, good. Write a class Socketmon in which Python defines a socket monster, implementing the following rules and actions. Monsters have the following properties. Okay. Monsters have the following methods. So let's just, usually with these, when I like have these on the real problem, I just, on the real thing, I just get started with them. So first things first, we know the name should be right here, Socketmon. Right? And now we want to have some properties. Name string. Type will also be a string here. And the reason the A is not included is because technically that would shadow an inner variable name, although in this case it's actually okay to do that. Level is probably a number in integers to be specific. Maximum minimum HP. Let's go with integers on those ones. And I'm going to use the data class stuff again, just because it's probably easier. Because, well, Glenn, are you good with that? Do you understand what the data class does?
So far, yes, I think so.
Okay, sweet. Like it's basically just auto-generating this for you. Based on these.
Wait. Oh, that. Yes.
Well, what this thing does here. I just want to make sure, because if you don't, I won't use it. If you do, I'm going to use it.
It auto generates the at the
init
start before. Yes.
It based on this. So it basically is generating that. So you notice I don't have the init here. It's doing it from this.
Right, and when you're putting the colon in string, you have to do that, right? Or are you just doing that for yourself to know what the values are?
No, here you don't. Technically speaking, you don't. It's good practice, in my opinion. It doesn't. I'm doing it for myself. I do it for myself. You don't have to put the types. They don't have to be specific types. None of this stuff you have to do. You could just do an init method without any of these types. Those are extra.
I just want to make sure, but I think I would do that myself just to make it clear, like to what type of values they were. I just wanted to make sure that it wasn't
right,
like a mandatory thing.
No, it's not. I always like to code that way. I think it's cleaner. I'm used to languages which force you to do that sometimes. So I think it's just a better way. But no, you do not. You don't have to do that. So it should be current HP. Oops, and I'll just change that to HP then. And status. Okay and depressed. Lovely. It's going to be string. And we can actually make it equal to okay because it says right there. That's the default. So now let's just double check. Must be initialized. Okay, that means that has to be provided by the when it's created. Socket monsters have one. That must be. So all of these must be provided. Socket monster minimum of hit points. That should be initialized too. Socket monsters have a number of hit points or HP. Hit points are reduced when a monster is the target of an attack. The field will keep track are equal to their maximum HP. Okay, so we just rename this to HP, and we're going to set it to max HP. I'm hoping it will let me do this. It probably won't. Probably will be an error right here. Yeah. So this will not actually work for a data class in this case because it's not straightforward enough. So instead, we got to do this. We got to do it manually. Data classes don't always work, as you can see. So we can just do self, name, type, level, max HP. And then what we do is we'll say here, I'm going to show it to you actually without any of this stuff. That way you can see how it's done. The kind of the bare minimum stuff here. Okay, so we have that. Now let's see. It's the following methods. Attack. Take self and another monster as arguments. Okay. This is a great one. And so here I'm going to just be clear here. So we'll call it enemy. And enemy is going to be a Sockemon. And so what we can do is we can actually just take that as a result. And then attack may reduce the target hit point according to the following rules. Where self is attacking and the target is, okay, is there no defend? That's funny. Oh, I guess you don't need that because the other guy's attacking. The base damage for an attack is level 1 minus level 2 plus 15, where level 1 is the attacker. So I'm the attacker. So like the current class is the attacker, right? So we want self.level minus other, like, or enemy.level plus 15. So, and you can see what I mean, right? We can assign these objects to any variable name like that. Plus 15. Okay. If the base damage for an attack is less than or equal to 0, oh, right. So what we can do here, we should actually clean this up a little bit. We can just say minimum of 0 in this. Oh, sorry, max it should be actually. So that way, we don't need to do, I just find these things are cleaner. Well, we don't need to have an if statement. We can just essentially accomplish the same thing. Because what if will do, what max will do is if A is less than B, B else A, basically. Right? And in this case, that's what we want, right? We want that with 0. So then, you following, Graham?
Yes, so far.
Sweet. Okay, so then the attack. So we've implemented the first two things. Socket monsters are always conscious of each other's emotional state. So an okay monster will never attack a depressed monster and a depressed. Okay. Interesting. Excellent, excellent, excellent. Okay, so first thing we can do, and I like to do this at the top. If self.status equals depressed, let's only do things as caps for this. You don't have to do it that way. Or self.state, or we should do brackets here just for clarity. Self.status, and I don't need the outer brackets. Status equals okay, and enemy.status is not equals to okay. It's just, I just think it's cleaner. I don't feel like it's probably cleaner to write it the other way actually. Equals depressed. Then what do we want to do? We want damage to be equal to 0, and I'll do it here actually. And this needs to go first, then we'll overwrite it with 0. And that way, essentially, what we'll do is that I assume double damage, double and half, right? So 0 won't affect those things. So because we can just use the 0 method, right? The other way is we could just instantly stop. And actually, it's probably a better way. So we should also indicate that this will return no value. And let's just do this. Let's return. So basically, we're going to stop the function execution. If it won't attack, stop the function execution and do nothing, right? That makes sense. So then we have the actual function part here. And so we can say damage equals to this. And then we can calculate modified damage. So let's do base damage. And then damage equals to self.modify underscore damage. I'm overriding the title because this is the correct way to do variable names in Python. Sorry, overriding what it says here. So then we're going to again have what we don't need to pass self, so it'll just be base damage. And we'll and another monster. So again, we need Sakimon. And in this case, yeah, I think we're always dealing with damage as integer. So oops. We don't need that. We just need that because we're calling it. So let's jump to that part then. Oh, and then I guess we might as well finish with this function. So let's just assume for the moment that this is correct. Then what we'll want to do is do a few things. Well, first we're going to want to say enemy.hp minus equals damage, right? And then we're reducing their HP. This is kind of how games work, actually. This is exactly kind of how game programming works. You have these entities, and they just do work on each other, and everything is an object. And that's why this is so useful. So then we can say if enemy.hp is less than or equal to 0, then enemy.status equals. And the attacking monster gains a level. And so we're going to call self.levelup. And no arguments, so we don't need to worry about it. And it doesn't return anything either, so we can just do this. Okay, so that's basically the attack function. Now let's implement these two methods, right? Because if I try to run them, it won't even compile the class. Like it won't define the class. Modify damage will be self. Oh, interesting. So here we have we actually don't need to take in base damage because I guess it doesn't matter. It just, so we're going to rename this function then damage modifier. And self now it'll be enemy, which is a Sakimon again. And then here, instead of self.modify damage, we'll want to do base damage is probably times damage modifier. And we're just going to put the enemy. And then here, we want to now indicate that we're going to return a float. And as well, since we need to deal with integers, we're going to want to do int. That way, if it's not an integer, because it could be 0.5, then we'll just round down. Honestly, it's a nice. Let's be nice to the Sakimon. So here we have level up. Sorry, we don't. We have this. So what we can do is we can say water is. Interesting. So if fire is attacking water, then it's weak. If fire is attacking, okay. Let's do this in this way. Let's do strengths. No, let's just hard code it, honestly. Whatever. So first of all, let's just say TYP equals to, well, we'll say this one and enemy. And this is specifically referring to the types. Will be self dot type enemy dot type. And I'm just doing this because I think it's shorter to type. But the truth is we shouldn't do that. It's less clear. So let's just not do this line. We have if self dot typ equals to fire, then if right, if the enemy is plant, then we're going to return 2. Right? Yeah, multiply by 2. Otherwise, we're going to return 1/2. And then elif, right? Because we actually don't. I mean, it doesn't matter. We can just do if enemy dot type equals to water. Then it's going to be a week. Right? And else, and I'm just going to do this later. I'm going to do this at the end, actually. So if it hasn't returned, wait, so basically what I'm going to do is at the end, I'm going to say return 1. So for all of those cases where it's actually going to be like if both of them are fire basically, or both of them are water, then it will just not run any of these. And I don't feel like rewriting it 3 times. Now the thing to think about is, what if we ever want to change these? So the way I would do this is I would have some variables here, good or bad, normal, good equals 1/2, 1, 2. And that way, if you ever need to change them, you don't need to go through all of them. And I highly recommend doing this sort of stuff when you do your problems. Self.type equals plant, then if fire, well, let's do the good one first. It's probably water. Then return good. If and this is equivalent to elif, of course, because we're having return cases here. But here we actually want elif. Because if one is fire and the other one is also fire, well, we don't need to waste our time with these, even though the truth is they'll never be true simultaneously. So it actually doesn't matter. We can just use if statements. If enemy.type equals to fire, return bad. And then finally, if self.type equals to water, if fire, return good, if enemy.type equals to plant, return bad. Otherwise, return normal. Make sense? Pretty ugly function, but whatever.
Yeah, I get that. Yeah, it makes sense.
Yeah. There probably is a way we could have done it with like tuples and dictionaries and whatever, but I just there's a point where it's actually just easier to do it this way, and this is probably one of those places. Okay, let's write a heal function, which is again pretty straightforward. And this one is just going to set our health to max. So self.hp equals self.max HP, and self.status equals okay. Right, because it said heal full hit points and cure depression. Okay. Def level up. And so now we're going to take no arguments. Okay. Okay, so monsters are restored to full hit points, so we can do that. Self.heal. Monsters' maximum hit points are increased by 5%, so we need to do that first, actually. Round it down. Okay, good. So self.maxhp going to be equal to, and I would use the times equals here, right, and do times equals 1.05, right, so they want it. But the issue is we want to make sure it rounds down, so instead we'll have to do right, and that will work. That will effectively round down, although technically it's probably more correct to do with the math.floor thing, but I don't care. And then finally, the monster's level increases by 1. So self.level plus equals 1. And you can see that really these just function as normal variables, these class variables. Finally, what time is it? We have a string method. And so basically this is going to give us a default output here for the string. So essentially what I want to show, so this already works. Let's try this. Oops. Did it right for all of them and then failed in the last one. That's pretty sad. Oh, maybe you can't do that here. Pretty sure you can. Maybe I'm just not doing something right. Anyways, you get the idea. There must be some way. But anyways, let's, what I want to show here. I really wanted. Oh, I see. Okay, we'll get there in a moment. So let's just run this. So we can do. Now, what do you think will happen? Well, it's going to print this weird, useless thing. And basically what this is actually saying is it's a document object, and then it's printing the memory address. This is a default behavior for when you convert an object to a string. So there needs to be a function which Python can call that takes your object and turns it into a string. Now, it must have this signature. It's a similar way for like all kinds of things, like multiplication, equality. Python uses these functions to basically determine how to do everything. And so the string function will automatically be called in a case like print, where you would normally call str like this, or actually you might manually need to do this. We'll see. But that basically does the same thing. So let's try this. So basically what we want to do here, and of course it's going to return string, not that I need to specify that, is, oh, that did not work. We want this. And so what we can actually do here is use those same f strings that I talked about. So we can do level, and then instead of these spots, we're just going to say makes sense. So when I call this, it should now automatically, or it might, yeah, it will automatically call the string function because it now exists. And you can see that's a lot more useful information, eh? But I should note that if you just do this, for example, I don't think it will do that. See? So you can see that this still exists, but it only will do this when it's actually calling, when it's supposed to call the string function like this. Now, one thing that Professor wanted is oh, okay. Let's add one more thing here. What we want to do is we want to now show you guys how to extend a class. So did you follow that all, Graham?
Yeah, mostly. I think I'd have to read over it to get a complete understanding of it, but I followed what you did most.
Okay, cool. Perfect. So then the final thing I want to add is let's extend the class. So we're going to create a new class called nameSockemon, which will add a nickname basically. Okay. Now what I want to show here, oops, it's not def, that's a class, is that what we want to actually have here is So there's a specific syntax for extending a class where you just take the brackets here and then you put the class name instead above. What that's actually going to do is going to automatically copy over all of these methods. Okay, everything in this class is now existing here. So if I actually do this, watch this. And what pass does is basically is just allowing me to have nothing here. And I run this cell again. And now I do this with a capital N. I won't get an error anymore. I do get an error. Oh yeah, because I have to modify the init method. But if I take this away, you'll see that I now have the same thing. And it works right. There's no error. Everything is copied over. And in fact, even the integer was the init was copied over. The problem was that it was copying the init from the previous one, and we actually need to modify it. Okay, so how do we modify it? Well, essentially what we do is we just modify the methods that we want. So first of all, we need to change the init method because we need to take in a user-specified nickname. Okay, let's do that. So what we can do, we can just copy and paste this. And yes, unfortunately, well, I'll actually show one thing. Now there's two ways we can do this. We can do it like this. And then we'll add at the top bottom self.nickname equals nickname. Okay. But there is a cleaner way, which Python offers. And it basically is how you can call functions from what's called a superclass, which is the class you're extending from. And essentially what you do is you type this, and this will give you a reference to the, this will basically be the object above, the parent object. And so what you can do is you can do this, super.init. Next, you might just be able to put it inside super, but I don't feel like doing that. Name, type, level. This is nice because instead of having to copy out all those things, this will actually just let you reuse this right here. Because super is going to point to Sakimon, and then it's pointing to this. Does that make sense how that works?
Yes, I get that.
Okay, sweet. So then all we want to do is, string contain, and then and one new method, NameWriter. Okay, sure. Okay, good. So let's just we'll call it set name actually, and we can just do name here. Oh no, I said I wasn't doing that, so let's not do that. Oops, I guess I did include that in some spot that I didn't need to. And I did that here as well when I didn't need to. And I did that here too. It does make it more clear though, so that's I'll take my refuge in that. But anyway, and so then all we need to do here is say self.name equals name, and you'll notice that I have no intention here of utilizing a what's it called, the super method again, because it's copying over the name thing. So if I do this, we will expect it to go as expected. And if we wanted to, again, we could do the same thing. So we could say def string self, right? And we could say let's do it like this. Return a new f string, because f strings are supreme. And then we'll say nickname, nick. And then we'll put the nickname, self.nickname. And then we'll put, maybe 3 dashes. And then we can just say same thing. So super.str. Actually, it's probably cleaner to do it like this. No, it's probably cleaner to do it this way. str. And I think this will work. Oh, f string unmatched because of that. Hey. Make sense?
Think so. Could Could you remind me what the F with the apostrophe does? I think we discussed it yesterday, but I just can't remember.
This. You do this, it does this. When you do F, it takes all of the things inside these braces and evaluates them as Python expressions. So that's how I'm getting the numbers in there.
Okay.
It's taking the value, like the variable self.nickname, and putting it in that spot. And same thing here. It's like this is the same result from here, but only over here, because what we've done is we've evaluated it as a Python expression. It's basically like I could have just done this. The truth is I could have just done this, right? But I think it's not as nice.
Okay.
Does that make sense?
Sort of, yeah.
Okay. That's really all. Do you have any questions?
Not right now. I'd probably have to like give it a try and like do that kind of stuff before I have any questions, because I kind of understand it, and I think it makes sense, but I think the only way I could have any questions is if I actually give it a try. As right now, I think I understand most of it, but not fully, probably.
I know it makes sense. So what I'll probably do, I'll probably upload this code to
that'd be good.
To did you see what I did with one of the previous weeks? I think when I uploaded it here.
Yes, I saw that. Yeah.
And I also put on GIST here, so I'll probably do the same thing.
Yeah.
But, like I found this was quite a good way in the end, where you could see all this stuff through here. So I'll probably do the same thing for this code, and the video will be posted as well, so you feel free to come back to it. And then just feel free to email or come to office hours if you have issues.
Yeah, I think I will. I think.
Okay.
I have to get through more of the assignments before.
For sure. All right. Well, if there's nothing, then thank you for coming. Wow, I guess yesterday we ended like 25 minutes late. Today we ended 5 minutes early. Perfect. Bouncing out. All right. Actually, technically it's not. Technically it's still 5 minutes late. Yeah. Oops. All right. Thanks for coming, Graham.
Yes, thank you.
Bye-bye.
Bye.